This video is going to cover how to graph a quadratic equation in standard form. So first things first, we need to know what standard form is. So standard form of a quadratic equation is in the form y equals ax squared plus bx plus c. A, b, and c are just numbers, okay, integers. They could be decimals, fractions, they can be. I don't believe we're going to have that in there, but they very well can be. So just like when we had vertex form, we need to do a couple different things when we can graph. So in vertex form, remember the first thing that we needed to do was find the vertex. Okay, but in standard form, I can't find the vertex first because it's in standard form. I don't have the vertex already given to me. So in standard form, the first step that I have to do is find the AOS, find the axis of symmetry. In standard form, there is a specific formula to use for the axis of symmetry. The formula that we're going to use is x is equal to negative b over 2a. Remember, negative b just means the opposite of b there. So b is negative 12, so the opposite of b is positive 12. Then divide by 2 times a. In this case, a is 2. So I get 12 over 4, which is 3. So the AOS, like vertex form, is x equals 3. So what are we going to do with that? Well, I'm going to go on my graph, and I'm going to draw a vertical line dotted through x equals 3. So that is where my axis of symmetry is. Now remember that the axis of symmetry also contains the vertex. So how do I find the vertex now in standard form? So what happens is, so your second step is you're going to find vertex. And how we do that is I'm going to substitute or plug in the x value. Remember, the x value is just the AOS. Into the equation and solve for y. So I'm going to plug it in. So I get 2 times 3 squared minus 12 times 3 plus 14. Again, using your calculator or your brain, you can figure this out as 2 times 9 minus 36 plus 14, which is 18 minus 36 plus 14, which is negative 18 plus 14, which is negative 4. So the vertex is the x coordinate, the axis of symmetry, comma, the number that I found when I plugged it in. That is my vertex, 3, negative 4. So on the axis of symmetry, your vertex is down here at 3, negative 4. The third step is going to be the same as vertex form. So what we're going to do is we're going to plug in numbers to the left or to the right of the axis of symmetry into x into the equation, and we're going to find out what the y value is, plot them, and then we'll get our points. So let's do that. So again, we're going to plug in numbers to the left or right of AOS. Okay, so I'm going to plug in 2 because 2 is to the left and they're smaller. You can very well plug in 4, but I'm going to plug in 2 because it's smaller. So 2 times 2 squared minus 12 times 2 plus 14. That gives me 2 times 4 minus 24 plus 14. So that's 8 minus 24 plus 14, which is equal to negative 16 plus 14, which is equal to negative 2. So I plugged in 2 and I got negative 2. Well, just like in vertex form when I graphed, this is 1 away, so 1 away this direction goes there. Okay, remember I have to reflect. That's what that axis of symmetry means. It's my reflecting line. Now remember, I did say that I need 5 points. Well, I only have 3, so I have to plug in another number. Let's plug in 1. 2 times 1 squared minus 12 times 1 plus 14. That's 2 times 1 minus 12 plus 14. That's 2 minus 12 plus 14. That's equal to negative 10 plus 14, which is equal to 4. You can very easily do that a lot faster on a calculator or in your head. I'm just showing you every step of the way. So if I plug in 1, I get 4. So that's up here. Well, guess what? That's 2 away from the line. So if I put 2 away from the line in the other direction, I get my ordered pair right there. Now I have 5 dots. So now I can graph my quadratic equation. Remember, it has to look like a U. It comes rounded at the bottom of the vertex. Again, now the 4th step, we need to make sure if it's a min or a max. Well, just like in vertex form, if A is bigger than 0, it is a min. If A is less than 0, it is a max. Well, what is my A? My A is 2. That is a positive number. So I get a min. Then I need the value. Remember, the value of the min is just the y coordinate of the vertex. So the y coordinate. So my min is at negative 4. Let's continue. This is another example. This is probably the last example I'll do for graphing quadratics in standard form. So the first thing I need to do is to find the AOS, the axis of symmetry. How do I do that? X equals negative b over 2a. Negative b just stands for opposite. So our b is positive 6. So the opposite of it is negative 6 divided by 2 times. Our a value is negative 1. So I get negative 6 over negative 2 is equal to positive 3. So AOS is x equals 3. So again, I have my dotted line going down x equals 3. Second step is to find vertex. How do I do that? Well, my vertex, we already know this number is going to be the x coordinate of the vertex. How do I find the y value? You plug the x value into x here, and whatever you get out is your y. I get negative of 3 squared plus 6 times 3 minus 6. So that's negative of 9, 3 squared is 9, plus 18 minus 6. Negative 9 plus 18. Negative 9 plus 18 is 9 minus 6, and I get 3. That is the y coordinate of the vertex. So 3, 3. Plug it in, and then we graph it. 3, 3. Our third step, remember, is we're going to pick points, pick numbers, or in this case, they're really x's, right? They're really just x's to the left or to the right. Left or right. Of AOS. So let's pick a number to the left of it. 2. Negative of 2 squared plus 6 times 2 minus 6. Negative of 4. 2 times 2 is 4. Plus 12 minus 6. That's positive 8 because negative 4 plus 12 is positive 8. Minus 6 is 2. So I get 2. So if I plugged in 2, I get 2. Right there. That means that I'm going to reflect it 1 over this way, and I get my reflecting point. So now I have to pick another one. So I'm going to pick 1. Negative of 1 squared plus 6 times 1 minus 6. Negative of 1, because 1 times 1 is 1, plus 6 minus 6. Negative 1 plus 6 is 5, minus 6 is negative 1. So if I plugged in 1, I get negative 1. That's 2 away. So 2 away in this direction is now my reflecting point there. So now I can graph. And there's my graph for this particular equation. But again, the fourth step, we need to see if it's a min or a max. I come back to my a value. In this case, a is equal to -1, right? That's from the x squared term. The number in front of x squared is -1, which is less than 0, which makes it a max, because that vertex is the highest point on the graph. But now what's my value? Well, guess what? That's where the y-coordinate is. The y-coordinate is 3, so that goes here. So this problem has an axis of symmetry of x equals 3, vertex of 3, 3. I picked 2 numbers, plugged them in, and got those 2 points plus 2 more because I reflected, and then it is a max because a is less than 0, and then my value of the max is 3 because that's the y-coordinate of my vertex. This concludes graphing quadratic equations in standard form.